Today, we're going to talk about a creature that just completely breaks all the rules of what a fish should be. We're looking at the African lungfish, an incredible survivor with a 100 million-year-old secret. And honestly, it's been hiding in plain sight this whole time. So, let's dive in. You know, this quote from back in 1954, wow. It just perfectly captures the strange, almost mystical vibe of the lungfish, doesn't it? It does not follow the water, but the water comes to it. It hints at this incredible power, this ability to sort of command its environment in a way that almost nothing else can. And that really leads us to the big puzzle here. I mean, it sounds completely impossible, right? A fish living on land for years? The whole fish out of water saying exists for a reason. It's supposed to be a classic example of something that just can't survive. But the African lungfish, its scientific name is Protopterus, it has this wild strategy that completely flips that idea on its head. It can thrive in conditions that would be an absolute death sentence for any other fish. So the real question is, how on earth does it do it? Okay, so to really get how this creature has been around for so long, we've got to look at its most amazing ability. You could honestly call it a superpower. It's this biological trick that literally allowed it to outlast the dinosaurs and just keep adapting to a world that never stopped changing. So the secret has a name. It's called estivation. And here's how it works. When the sun is just relentless, baking the earth until all the water disappears, the lungfish doesn't panic. It just burrows down deep into the mud. Then it secretes this cocoon of mucus all around itself, basically sealing itself into a little moist chamber to just wait out the drought. It's like a state of suspended animation. It can survive for years like this, with its metabolism slowed down to a crawl. And here's the kicker. It's what's known as an obligate air breather. That means it has to breathe air anyway, so it already has the perfect equipment to make this incredible switch from water to land. All right, so now that we know about its superpower, let's put on our detective hats. We're going to become paleontologists for a bit, because our mission is to trace the 100 million-year history of this animal. But I gotta warn you, the evidence we have to work with is, well, it's incredibly limited. This is going to be a real puzzle to piece together. See, for a fish like this, the skulls and skeletons are just too delicate. They almost never survive long enough to become fossils. So what are we left with? Well, pretty much all of our evidence comes from one incredibly tough part of the animal. Its fossilized tooth plates. That's right, teeth. Just imagine trying to reconstruct an entire family tree for millions of years using only teeth. That's the insane challenge paleontologists are up against. The entire 100 million-year story of Protopterus is basically written in these tiny fragments. And this is where our detective work gets really tough. I mean, these tooth plates are notoriously hard to read. For one thing, they change shape as the fish gets older. On top of that, the teeth from the upper jaw look totally different from the ones on the lower jaw. And then there's just a huge amount of variation from one fish to the next. So trying to tell different fossil species apart, it's incredibly difficult. And that is why the lungfish's family tree has been such a massive mystery for so long. But as challenging as it is, these teeth do tell a story. So let's go back, way back. Let's travel to where the story begins, in an ancient Africa that you and I would find completely unrecognizable. Okay, we're going back 100 million years. That's Ma for mega annum. We're in the late Cretaceous period. To put that in perspective, this is the world of the dinosaurs. And it's right here in this ancient world that we find the oldest confirmed fossils of the lungfish genus Protopterus. At this point in history, Africa and South America had only recently drifted apart. The whole planet was just a very, very different place. Now, the environment here is absolutely crucial to the story. See, the earliest lungfish fossils, they're not found where you'd probably expect to find them today. Nope, they're all concentrated up in northern Africa. Back then, that whole region was a warm, humid, tropical paradise, probably covered in these incredible, lush rainforests. This was the original home. This was the cradle of the African lungfish. So, for tens of millions of years, the lungfish is just thriving up there in the north. The fossil record is packed with them at all these freshwater sites. Everything's going great. And then, poof, they disappear. Just vanish from the record. This abrupt vanishing act is the absolute central mystery of our detective story. And you can see the mystery laid out right here. On the left, that's the early distribution. Fossils all over northern Africa. But then look at the right. This is the Neogene period, starting about 23 million years ago, and they're just gone from the north. completely gone. Instead, they suddenly reappear in a brand new area, down in this cradle around the equator. We're talking the Congo and East Africa. It's a total geographic flip. What happened? So let's just lay this out on a timeline to make it super clear. For more than 70 million years, the lungfish story is a northern story. Then we hit this ghost period. They just disappear from the record up there. And then, starting around 23 million years ago, they pop back up in a new southern home. And it's from this new cradle that the modern species we know today eventually evolved and spread out. So, yeah, the big question remains, what on earth happened in between?
Well, it turns out the answer to this mystery isn't really biological at all. It's geological. The lungfish didn't just decide to pack its bags and move south. No, the very ground beneath them was literally being torn apart. And it was this massive continental-scale catastrophe that actually created the perfect conditions for the modern lungfish to evolve.
This is the chain reaction right here. It all started with the formation of the Great Rift Valley, a huge tectonic event that literally reshaped the African continent. This process completely rerouted ancient rivers, creating all these new lakes and basins. At the exact same time, the climate was shifting. It became way more seasonal, which meant more intense and more frequent droughts. Now, for most animals, this would be a disaster. But for an air-breathing fish that can sleep in a cocoon, these new, challenging, fragmented habitats, they were like an evolutionary playground. It was the perfect pressure to drive the rapid evolution of the modern lungfish. And the result of all that intense geological and climatic pressure? It's the family of 4 distinct species of Protopterus that are alive today. They are the direct descendants of the fish that survived that incredible upheaval. And here they are, the living, breathing proof of that whole story. You can really see their diversity right here, and how each one is perfectly adapted to a specific little niche that was created by that changing landscape. You've got Protopterus annectenens hanging out in the shallow swamps. Then there's P. aethiopicus in big, permanent lakes like Lake Victoria. You'll find P. doloi in the massive Congo River basin, and P. amphibius over in the coastal regions. This modern diversity, it's the living proof of that ancient geological story we've been uncovering. So after this incredible 100 million year journey, what's the big takeaway? Well, the story of Protopterus isn't just about some weird fish that can breathe air. It's actually a really profound lesson in what it takes to survive and adapt on a truly planetary scale. When you boil it down, the lungfish is the ultimate survivor. It's a true living fossil, a kind of blueprint for resilience that has barely changed its basic form for eons. That superpower we talked about, breathing air and sleeping through droughts, that was the golden ticket that allowed it to endure while countless other species vanished. And more than anything, its story shows us, in the most dramatic way possible, how the fate of life is completely tangled up with the ever-changing geography of our planet. You know, the lungfish didn't just get through one environmental crisis. It survived tens of millions of them, all by relying on its one-of-a-kind adaptation. So, as we find ourselves facing our own period of really rapid environmental change, maybe it's worth asking, what can this 100 million-year-old survivor teach us about what it really takes to endure?